How it works. Geothermal heating and cooling works by tapping into the constant heat source that is found 5 feet below the Earth's surface. In the Northeast, this temperature is approximately 53 degrees. Direct exchange geothermal, or DX, outperforms water source geothermal systems by 25% and is the most efficient system on the market. That's because DX does not require electrical circulators, which use additional electricity. DX only requires one heat transfer, and DX utilizes copper piping, which has superior heat transfer properties instead of the plastic tubing used in water-based systems. Our equipment and installation are what separates us from everyone else. We drill our boreholes to a depth of 100 feet. When drilling to 100 feet, we are very likely to encounter moist soil and/or rock conditions, which are preferred for conductivity. Each borehole is drilled vertically and is spaced 7 feet apart. This prevents the phenomenon of ground loop interference. Envision each borehole as a 7-foot diameter cylinder that uses this area to gather the Earth's energy. When ground space is a concern, a teepee-style or slant configuration can be used to reduce the area needed for drilling. Notice the reduced surface area needed at the top of the boreholes. Here's a simplified version of how a heat pump works when heating your home. All heat pumps have a compressor and an expansion valve that manipulate refrigerant. A refrigerant has 2 phases, gaseous and liquid. Refrigerant works on the basic principle that if you raise the pressure, you raise the temperature. If you lower the pressure, you lower the temperature. This is all done with a compressor and an expansion valve. Let's say the refrigerant starts its journey in its gaseous state and enters the compressor at 30 degrees. The compressor compresses the gas, which increases the pressure and raises the temperature to 160 degrees. The refrigerant travels to a coil where a fan blows across it. The air blowing across this coil absorbs the heat energy and distributes it throughout the home. As the refrigerant leaves the coil, it condenses back to its liquid state and moves toward the expansion valve at 85 degrees. The expansion valve is basically like a dam with a small hole. When the refrigerant passes through the expansion valve, the pressure rapidly decreases and the temperature falls to 20 degrees. It then moves toward the TXV valves. These valves control the amount of refrigerant distributed to each ground loop. The refrigerant is then piped out to the well field and down the vertical boreholes where it begins its transformation back to a gas. As it transitions back to its gaseous state, it absorbs heat energy from the Earth and travels back to the compressor where this ingenious process is repeated. When cooling is desired, this process is